Hi everyone, today we're gonna be talking about series. So what are series? Series is a data structure. So first of all, it's a data type. Now, it is a data structure in pandas that holds an array of information along with a named index. The named index differentiates this from a simple numpy array. So having a pandas uh, index or named index is different than having a simple numpy array. Formal definition. The formal definition of pandas is you can say is one dimension in array with access labels. Yes, so the first main type, data type we will learn about for pandas is series data type. Let's import pandas and explore the objects. A series is very similar to NumPy array. In fact, it is built on top of NumPy array object. What differentiates the NumPy array from a series is that a series can have access labels, which means that NumPy can't have labeled access labels, meaning it can be indexed by a label instead of just a number location. It also does not need need to hold the numeric data. It can also hold any attribute Python object. So first of all, we need to import NumPy and pandas. So we import them this way. So creating a series from Python objects. Obviously, we have the help method or help function. We can use it, and Python will explain what we can use with this method. So here we have a lot of stuff that explains how we can use it, what can we use it for, and other stuff. So here, index and data lists. We can create a series from Python lists. So this is an example of creating a series from a list in Python. So here, for example, we have my index, which is USA, Canada, Mexico, and we also have my data, which are part of our series, 1776, 1867, 1821. And now we're gonna create our series. So this is how we create it. Is first of all, we obviously need to name it, and then we need to type pd.series as capital, and then type data. So one of the things that pd-series method takes is data. So here we told Python or pandas that my data is this. So now it understands what it's supposed to do, and when we run my seer, it gives us this series. This is a simplified series, and this is a small version of how it may look. We can also change the index as we read here. Is that we can have labeled indexes. So how can we do that? For example, here we created my index, which has USA, Canada, and Mexico, by typing pd.series data equal my data, as we did here. This is my data, which are the columns, and my and index. We pass the index method, and for example, this is not really supposed to be my index. It could be named anything. For example, we could name it I, and it could still work. If we replace it here and run it, it will display the country names as indexes, yes, instead of numeric values. So let's change this back. Run data equal so we're creating random data by using NumPy. Our range is from 0 to 100, and we want 4 values. So we got some random values: 84, 18, 12, and 69. And now we have a different data series that we're creating. So now we have names Andrew, Bob, Claire, and David, and their ages is and now so first of all we wanted their ages. So their ages right now is random data, which are these random generated numbers. And when we type in pd.series rand data, which is in this case is my data, we're not really obligated to type data each time. We can just arrange them properly, and Pandas will be able to do it by itself. So here, random data is my data that I want it to be displayed inside of these columns, and names will be my index. And as we can see, this is a small data series. We can also make a data series by using a dictionary, as you can see in this example. Ages is the dictionary name, and Sami is it acts as our index, and 5 is our data, and yeah, and so on. So Frank is also an index, 10 is our data, Spike is our index, and 7 is our data. So when we type ages, for example, this is how it would display normally in Python, but if we pass it through pd.series ages, this is how it comes out as Sammy 5, Frank 10, and Spike 7. So these are their ages as an example. Key ideas of series, named index, we can name the index. So we're making a data series from what do you call it? A dictionary. We have 2 dictionaries here which are named Q1 and Q2. How do we convert these into data series? Is we simply, for example, name it cells Q1 equal to PD series Q1, which is this, and cells Q2 equal to PD series Q2, which turns both of them into a data series. So when we type cells Q1 and run it, we have this data series that we can see according to this this line of code and this line of code. Cell call values based on named index. We can call our values based on indexes. So for example, if I call Japan from cells Q1, as we can see here, it's 80, or here in the chart. So if we call Japan, this is the equivalent of indexing in normal Python. So, but this is how you index or call a specific part in Pandas. So when we typed in Japan, we need to make sure that it is also it's case sensitive. We can't type J as capital or any letter different than how it's written originally, and we can't type extra spaces. So when we call Japan, so as you can see here, it's an index and its value is 80. That's why it's displayed as 80. We can also call it with normal indexing by calling 0. As you can see, it gave us 80. If we change it for 3, for 3, for example, it will give us 250. It will give us USA. As you can see, in Python we start from 0, 0, 1, 2, and 3. So it gave us USA 250. Be careful with potential errors. We can't type a wrong name that isn't in our data set. So if we type France, it will let's remove this and run it. It will tell us that France is not there, because as if you check here for cells Q1, we don't have France, so it's giving us an error. That's why it's not working. So we need to take care from mistyping. As I said, accidental extra space. So in the data we have USA, and it's uppercase as the data set, but it has some extra spaces. So if we run it, it will tell us there is new USA, and as you can see here, it counts a space here. So it's not working because we gave an extra space, and that's not allowed. As I said, the capitalization mistake, if we run this cell, it will also give us an error because USA here, it's written as capital, all of the letters, and not lowercase. We can grab just the index keys. So for example, this is a method we know in Python. So if for example we type sales q1.keys, it will give us the keys, which are our indexes in this case. Japan, China, India, and USA, and print it here. We can perform operations broadcasted across entire series. So for example, this is like NumPy. We can just say we want to multiply each value in my data by 2. So if we just simply multiply by 2 like this, it will multiply everything in our data by 2. So for example, Japan was 80. When we multiplied it by 2, it gave us 160, etc. Yes, we can also, for example, divide by 100 and it will give us the values. But in this case, we are doing this with the sales Q2. So we have different values like Brazil, China, India, and USA. Between series, we can notice how Pandas informs you of a mismatch with NA. So here, for example, we wanted to concatenate our two data series, but we have some non-values here. That's because Brazil isn't in one of the other datas in the other in the other series. So for example, sales Q1, we don't have Brazil here, but we have Brazil in sales Q2. That's why we're having a non-value. But for example, China, India, and USA, they are both present in sales Q1 and sales Q2. That's why we get 950, for example, 410 and 510, because they are both present. So yes, we can. There's another way we can skip this issue. Is you can fill these with any value you want. So for example, if we type sales Q1 dot add sales Q2, so this is literally the same as doing this, but the only difference is we have this method called fill value equals 0. So when we type fill value equals 0, so it means, for example, if one of the data is not in the other data set, we just give the value 0 or anything. For example, if we type any number else, it will be false. It will change how the data works, and we don't want that. So that's why we simply just type 0 instead of ruining our data, so we can have it accurate. And yes, as we can see, Brazil here was, let's go up, as we can see, was 100. So when we place the value as 0, it became just 100. So yes. And this is for the first data book.